Hey, ladies and gentlemen, we are looking at 8.7 notes on solving polynomial functions. So we're doing some more with polynomial functions, but today we're going to do some factoring and remind ourselves of that. So I want you to go ahead and pause the video here and try factoring these three problems. These are things we factored back in Algebra 1. We factored them again here in the first part of Algebra 2. So I want you to pause the video here and factor these and then come on back. All right, hopefully you took the time to factor these. In the first one, you always want to look for a greatest common factor first. We don't have one here. Because we have something in front of the x squared, we need to times it by the c term. So 2 times negative 15 gives us a negative 30 in the top of our big X and a negative 7 in the bottom. So our two terms were negative 10 and 3. So I put those into the middle, and then you have to do factor by grouping. I took a 2x out of the first two terms and had x minus 5 left. And I took a 3 out of the second two terms and I have x minus 5 left. Because both of them were the same inside my parentheses, I could put them into one and my 2x plus 3 into the other one. Problem 2 is just a greatest common factor problem. You didn't have to do anything else with it. And then problem 3 is a difference of perfect squares. There's no b term, so x minus 9, x plus 9. Notice with all three of these problems, there is not an equal sign, so you do not have to move forward and solve for the variable. All right, so when factoring polynomials, take out the GCF or the greatest common factor first and then factor if possible. All right, so I want you to pause the video here and fill in your table for difference of two squares, and then we have sum of two cubes and difference of two cubes, and that is something new we are going to look at today. All right, so hopefully you are pausing and getting those written down. All right, so you have them written down. Sum of difference of two squares, that's when we are subtracting two terms that are squared. Sum means adding two cubes. These are things that are cubed. So I will make sure that we find some space to jot down your list of perfect cubes, but things like 2 cubed is 8 and so on. Then we have difference of two cubes, and so we're subtracting two things that are cubed, and they will just follow these two patterns. So you will want to have these either jotted on the top of your notes or have your notes easily accessible for when you're doing your work. All right, so factor the following polynomials. It says hint, this for 4 and 5, difference of or sum or difference of cubes. So you, like I said, you want to have the two formulas easily accessible. So I look at this and it's a sum because I have a plus, and I know that 125 is a perfect cube. So this is x cubed plus 5 cubed. So x is my a, x, and 5 is my b. So I'm just going to plug them into my sum of two cubes formula. So I have x plus 5 in my first parentheses, and my second parentheses is going to be x squared minus, now I have to times a times b, so you always want to write the number first, so 5x plus b squared. And what is 5 squared? It's 25. And that is how we leave the problem. You don't have to go any further than that. So let's go ahead and repeat it here with problem 5. Now in problem 5, I see an 8 and a 27. Those are perfect cubes. 8 is 2 cubed, so this is 2x cubed for my first term. And then 27 is, and I don't really need a parenthesis, is 3 cubed. So my a is 2x and my b is 3. So I'm going to plug them into my difference of two cubes. So I get in my first parentheses 2x minus 3. And then in my second parentheses, now it says a squared. So I'm taking 2x and I'm squaring it. So you have to distribute that into both of them. And here we distribute. There's no plus or minus in there. So we get 4x squared minus a times b. So that's 2x times 3. So I get 6x, and then, oops, that was a plus. And then I get plus b squared, and 3 is b. Oops. So 3 squared gives me 9. All right, that one was a little trickier when we have something in front of a term, not just a variable or just a number. Okay. All right, let's go ahead and look at problems 6 and 7. It says, hint, difference of perfect squares. These are both perfect squares. And it says, remember to factor completely. Okay, so a squared, and then we have 7 squared. So a is our first term and 7 is our second one. So a minus 7 and a plus 7. That's all because I can't go further with those. Now if we look here, my term is a x squared squared, and then I have 9 squared. So I have x squared plus 9 and x squared minus 9. Now the hint said remember to factor completely because this second one is still a difference of perfect squares. So I get x squared plus 9 and then x minus 3 and x plus 3 because that can factor out into both of those. All right. Number 8 and 9, it says hint, factor like general trinomials. So look at this. This is similar to problem 1, but we're looking at x to the 4th and x squared. But we're going to do it the same idea. We're going to set up a big X, and negative 50 goes in the top, and negative 23 goes in the bottom. So take a pause and think about what multiplies to negative 50 and adds to negative 23. Well, that's negative 25 and a positive 2. All right, so this time, can I use my shortcut, you guys? Yeah, absolutely, because there's nothing in front of the first term. But instead of just saying x minus 25 and x plus 2, this time it's going to be x squared minus 25 and x squared plus 2. We have that same remember as our last slide, factor completely. So if we look here, x squared minus 25 is actually still a difference of perfect squares. So we can change that to x plus 5 and x minus 5. And then we have our x squared plus 2. Okay, so it's just the same thing we do if it was a trinomial that's a squared, a quadratic, but this time we just separate it into x to the 4th. I want you guys to pause and try this one on your own. I think you guys can do this one. All right, so if we look here, multiplies to negative 63 and adds to 2, that gives us our 9 and negative 7. And I split it, x squared plus 9, x squared minus 7. So the question I have now is this the answer, or can I keep going? And in this one, this is the answer. Now, some of you might be going, but this one, those are perfect squares, and they are, but it is a plus, so it is not a difference of perfect squares. You cannot split sums of perfect squares. All right, let's go move on to solving quadratic equations using quadratic techniques. So we have the same idea as before. We get x plus and x plus or minus in there. And then if we have x to the 4th, it's the same type of idea. But when we have equals 0, then you have to set each piece equal to 0 and solve for the variable. All right. So let's go ahead and look here. It has an equals 0, but we're going to treat it just like the last problems we were doing. What multiplies to negative 14 and adds to negative 5. That's our negative 7 and our positive 2. So we are going to put those into our shortcut, x minus 7, x plus 2. Notice it's just a squared term here. And then we're going to use zero product property. So x minus 7 equals 0. So I add 7 to both sides and I get x equals 7. And then x plus 2 equals 0. So I minus 2 to both sides and I get x equals negative 2. All right, so that one, not bad. We've done that plenty of times. I'm going to pause it here. Otherwise, I'm going to erase this just to give myself some more workspace. I thought I was going to erase it to give myself some more workspace. There we go. All right, so I'm going to pull out problems 11. Oops, 12 came first. Let's do problem 11. This one is the same type of idea. We are going to do what multiplies to 36 and adds to negative 13. Ooh, this one might be a little bit more of a stumper. How about negative 9 and negative 4? Because two negatives multiply to a positive and add to a negative. Because it's just a quadratic term, or I mean a fourth term there, we're going to go x squared minus 9 and x squared minus 4 equals 0. Ask yourself, can I go further? And I can. This is a difference of perfect squares. So we get x plus 3, x minus 3. And then x squared minus 4 is a difference of perfect squares. So x plus 2 and x minus 2 equals 0. So now I have four things I'm going to set equal to 0. X plus 3 equals 0. So we get x equals negative 3. X minus 3 equals 0. So we get x equals 3. X plus 2 equals 0. So we get x equals negative 2. Whew, right? And x minus 2 equals 0. So we get x equals 2. Four answers for this one here. Okay. All right, pause it if you need to keep writing. Otherwise, I'm going to go ahead and erase here. Oh, my screen froze on me. I'm going to erase here and get this cleaned up so we can pull out problem 12. All right, so looking at problem 12, same type of thing. I'm just going to get you guys started with this, and then I'm going to have you guys pause and finish it. So 225 and negative 34. All right, so our factors here, if it multiplies to a positive and adds to a negative, we're looking for two negatives. So we're going to have 9 and negative 25. All right, so pause it here and give this one a try on your own. All right, so take a look here. Hopefully you noticed you get x squared minus 9 and x squared minus 25. Those are perfect, difference of perfect squares. So we can split it out to those four pieces. And then we have four answers, 3, negative 3, 5, and negative 5. And really, if you wanted to say x equals positive negative 3 and positive negative 5, that would be a great shortcut to use in writing your solution. Okay, so we're going to clean this up again. We got one more to go through here, guys. All right, bring out problem 13. Oh, 12, you stay up there. Come on out, 13. It's a difference. No, not a difference. It's a sum of two cubes. Okay, so my terms are x and then 4 cubed. So a is x and b is 4. So I'm going to go ahead and use my sum of two cubes formula. So I get x plus 4. Okay, a squared. So I get x squared minus a times b, so 4x, plus b squared. So 4 squared gives me a 16. And then we have our equals 0. So the first part, this one's easy. We can solve that. X equals negative 4. We don't have to go, we can do that. I'm going to jot it down over here. So the next one, that trinomial, let's see here. Can we find anything that multiplies to negative 16 and adds to, or I mean positive 16 and add to negative 4? 1 and 16 doesn't work. 2 and 8 doesn't work. And 4 and 4 doesn't work. Okay, so what that tells me is if I can't factor it, it's prime, but a prime problem can be solved with quadratic formula. It means that my answers are not real. It means I have an imaginary answer. But we can do quadratic formula with this problem. So A is 1, B is negative 4, and C is 16. See, you guys, some of this stuff never goes away. It keeps coming back. So let's plug it into quadratic formula. So x equals opposite b plus or minus the square root of b squared. Hey, b is a negative, so put it in parentheses. Minus 4 times a of 1 times c, which is 16, all over 2 times a. All right, go ahead. And we are going to simplify underneath, oh, you know what? I think I ruined it. When I told you we couldn't factor it, I said it was two imaginary answers, but it just means that it's two not whole number answers. We could have decimals, but I ruined it by saying it was imaginary because I knew what the answer was. So we're going to keep going. We get 4 plus or minus, then underneath my radicals, negative 4 squared is 16 minus 64 all over 2. So when it subtracts in there, we get 4 plus or minus the square root of negative 48 all over 2. Now we can go ahead and simplify this. We can pull the I out, and let's see here. 48 is 16 and 3. So we can have 4 plus or minus 4i square root of 3 all over 2. Oh, we can do one more simplifying. Those 4 and 2 all simplify to 2 plus or minus 2i square root of 3. So not a real answer, definitely an imaginary one. And then don't forget we have that x equals 4 up there. All right, so big picture of this problem is factor, factor, keep going. And then if you get stuck on the factoring, try quadratic formula and we'll find our answers there. So if we looked at this graph, we know cubics, they have that shape that's kind of like this, or it's like this. So what that's saying is somewhere like our graph, our y equals, or I mean our equation might be here. Well, that's wrong, but this would be like at 4, and then the other ones are imaginary, so it doesn't touch down there. All right, I've babbled enough. There you go, ladies and gentlemen. Have a good day.